Hi everybody, Professor Mankowski again, and in this video we're going to go ahead and we're going to take a look at question number 2 on the worksheet. So I'm going to go ahead and I'm going to bring up the whiteboard again. Okay, and let's take a walk through. We're going to read the question, and then just like we did in question number 1, I'm going to start just by writing down every number that they've given me. Each year, Americans chew an average of 175 sticks of chewing gum, with a standard deviation of 21 sticks. If the distribution is approximately normal, find the probability that a randomly selected American will chew between 180 and 190 sticks of gum. Okay, now what I'm going to start to think about is labeling these numbers. The first one, 175, is mentioned with an average. So that tells me my 175 is going to be my population average mu. How do I know that's not going to be a sample average? Well, just like in the case of question 1, there's no mention of a sample anywhere. So my conclusion is 175 would have to go with mu as opposed to x bar. The next number 21 is mentioned in terms of the context of standard deviation. So 21 must be equal to my sigma. And on the last line, they're saying the probability that a randomly selected American will chew between 180 and 190 sticks a year. So 180 and 190 are probably going to be my x values. So what I'm going to do is I'm going to rewrite this in terms of x notation. Now, I'm going to say I'm looking for the probability that my x value can be between 180 is less than x, which is less than 190, just like so. And just for visual purposes, what this meant was my x value has to be more than 180 sticks. How much higher? Well, I have to just keep it less than 190. That's how I'm going to express an in-between notation. So now that I did that, I have to figure out what formula to use. And if I start with the 1 in the center, this probably is not going to apply because they did not give me an area. They didn't give me a probability in the question. So I'm going to cross this one out. I could consider the formula on the right, but they did not tell me a sample. There's no sample average. There's no sample size. So this one is going to be out. And it looks like the last one remaining is going to be the formula we use. And the tip-off is this one is for an individual data value, and they're asking us in the question about a randomly selected American. So I'm going to check my conditions, make sure that my normal distribution applies, and it does. They told me that my data is normally distributed. So I'm going to start to set up a curve here. And I'm going to put the curve about right up here on top. And the center of the curve, I'm going to go ahead, I'm going to do my population average, which is 175. And my x values are 180, so I'll put in 180 here, and 190. Okay, so what this is going to translate to is an in-between probability. Now, I would love to have a z-table that gave me in-between probabilities, but it does not. So what I have to do is I have to solve this in the context of less than probability. So I'm going to have to look up on my chart for the chance of being less than 180. I'm going to have to get the area of being less than 190. And I'm going to have to subtract both of these areas from each other. Now, what's going to make this one difficult is because there's 2 x values, it means that there's going to be 2 z-scores. So there's kind of twice as much work to go through in the exercise. So first thing I'm going to do is I'm going to take my 180, I'm going to bring that over here. I'm going to run my z formula on that. That's going to be 180 minus 175 divided by my sigma, which is 21. And if I do out the mathematics on that, I get 0.24. And that's with rounding to the nearest 100th digit. When I look at my z-table, the area for 0.24 is going to be 0.5948. So I'm going to come and I'm going to write that right up here, 0.5948. And now I'm going to run my z-score on the 190. I'm going to put that down right here. I'm going to say my z is equal to 190 minus 175 divided by 21. And when I do the math, I get 0. I'm going to have a 71. So now I'm going to have to go to my chart and retrieve the z value for that. I'm going to end up with 0.7611. So I'm going to write that up here. 0.7611. So that means my final answer I'm going to get by subtracting the smaller probability from the larger probability. So I'm going to come in and say answer is going to be equal to 0.7611 minus 0.5948. And let's see what we get when we work that out. 0.7611 minus 0.5948. That's going to be 0.1663. And that's going to be my final answer.